Transformation. 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 That was my impression of the praying mantis from A Bug's Life. Thank you. I worked hard on that. Okay, so for transformations, you've got two major things you want to remember. One, if anything is grouped with your x, so if you have something grouped with x, this is going to be a side-to-side horizontal shift. This is going to be a horizontal shift, and it is going to be the opposite. The opposite. Now, if this doesn't make sense right now, don't worry. I'm going to explain some more in a second. So just make sure you note these two things. If you have something outside of the group, so outside, the x is on the outside of the group, it is going to be a vertical transformation. It's going to be vertical, and it is not going to be opposite. It is going to be regular. So not opposite. I'll just say that's more confusing than necessary. It's just not opposite. Just note that it's regular. I'll go ahead and put regular. Okay, let's go see what all this mess is actually talking about. So here we want to graph the function f of x equals parentheses x minus 2 squared. So first what I'm going to do is I'm going to try to link this function to a parent function. Now I notice that here I have my absolute value of x minus 2 squared. That's kind of like my x squared. So my parent function is going to be f of x equals x squared. Okay, I'm going to go ahead and graph that parent function really quickly. Alright, here's the graph of my parent function, f of x squared. If you aren't sure what I'm talking about, look back at our parent function video. Okay, so here I'm noticing what's different. What's different between this x squared and this x minus 2 squared? Well, the change is grouped in the parentheses, and it's a negative 2. So since it's grouped, I know that this is going to be a horizontal shift. So I know this is going to be a horizontal shift. Go ahead and put horizontal down here. And my horizontal shift, remember, it's horizontal, so it's going to be opposite. So instead of minus 2, it's going to be plus 2. And all that means is I'm shifting every point in this graph to the right 2. So this point here at 0, 0, I'm going to shift that over 1, 2 points to here. My point right here at 1, 1, I'm going to shift that over 1, 2. So I'll get a point right here. I can shift my point up here at 2, 4 over 1, 2, and that point is now going to be over here at 4, 4. And I can do the same thing with all my other points. And if I do that, I'll end up with my new parabola right here, which looks very similar to my parent function, except it's shifted to the right 2. It's shifted horizontal because it's grouped, and it's opposite. This was a negative 2, so we shifted to the right. Let's take a look at another example. Here we want to graph the function f of x equals square root of x minus 3. So first, let's identify our parent function. I see we have a square root of x here, so I know that my parent function is f of x equals square root of x. Okay, I'm going to go ahead and graph my parent function now. Okay, here we have the parent function of f of x equals square root of x. Remember this long slope. Now here, notice that my shift here is not grouped with the x. If it was grouped with the x, it would be inside here, x minus 3. That would be grouped with the x. But we don't have that case. That's not the case here. We have it outside, so we know that the shift is going to be vertical. We're going to have a vertical shift. And remember, vertical shifts stay the same. So here we have a negative 3, so we're going to be vertically shifting negative 3. So all I do is go to each point. Here I have the point 0, 0. I shift that down 1, 2, 3. I'm going to have a point right here. I'm going to shift this next point down 1, 2, 3. I'm going to get a point right here. If I continue shifting, I'll get this point at 4 right here. I'll get this point over at 9 all the way over here. And my new graph of my completely shifted function is going to be right down there. Notice it's identical to the parent function, just shifted down 3. Okay, last example. We want to graph the function f of x equals absolute value of x plus 2 plus 1. Mr. Zonker, you must be crazy. No, I'm not crazy. This is possible. Notice we've got something graphed inside, grouped with the x, and then we've got something outside of the grouping, a positive y. All this means is we're going to have both a horizontal and a vertical shift. Same thing as before, we want to identify what our parent function is. Okay, my parent function is going to be f of x equals absolute value of x, because I've got an absolute value up here. I went ahead and graphed that ahead of time, so here I've got my basic parent function. Now, let's first take this 2 that's grouped with the x. This is grouped, so my horizontal shift, I'm going to say my horizontal shift is going to be the opposite 2. So that's going to be in the left direction 2, because this was positive and it's grouped, so we do the opposite. So we're going to shift left 2, and my vertical shift is going to be what's outside of the grouping. In this case, that's 1, and remember, that's going to stay the same. So my vertical shift is going to be up positive 1. So all I need to do now is go to each point and do those 2 shifts. So if I start here at 0, 0, I'm shifting left 2 and up 1. That's going to give me a point right here. I can do that with, let's take this point here. I could shift left 2, up 1. That's going to be here. Let's go ahead and do this point right here. If we shift left 2, up 1, that's going to be right here. If I shift this this point right here, left 2, up 1, that's going to be right here. I'm going to go ahead and do that with all my points that I have drawn out, and I'm going to end up getting an absolute value graph that looks, remember, just like the parent function, except the whole thing is shifted to the left 2 and up 1. So no matter what's happening to your original parent function, just remember, if it's grouped, it's a horizontal shift and it's opposite. If it's outside the group, it stays the same, it's not opposite, and it's a vertical shift. So using your knowledge of parent functions, you can actually graph a ton of functions without having to make big tables.